Okay, we're actually almost at 30 attendees, so I feel like we could probably get into it. But yeah, everyone, welcome to the PRIMRE finale. This is the last presentation in the Software Demo Days series, and I'm going to hand it off to John Weirs, one of the PRIMRE PIs.
Hi, thank you all for joining us today, and welcome to the final Software Demo Days for PRIMRE, the portal and repository for information on marine renewable energy. Next slide, please. I am joined today by our Department of Energy Program Manager, Swara Salim, and the PRIMRE Principal Investigators, myself, John Weirs from NREL, and Cesar Castilla from Sandia. Jonathan Whiting from PNL couldn't make it today. We're going to kick things off. We're also here with our Demo Days facilitators, Kelly Rule, Megan Anderson, who you already heard from Sandia, and Dominic DeCanio from PNL. Before we go any further, Swara, did you want to say any words?
Thank you so much, John. Hey, everyone. Welcome to the last software demo day of 2025. And I just, y'all have heard me give my spiel so many times at this point, but still I'll say it again. Demo days, this is an online event where we aim to foster cross collaboration on the various marine energy software that we here at WPTO fund. And the PRIMRE team, if I may say so myself, has been doing an absolutely exemplary job at running this series. Honestly, I'm really proud of the team and everything we've been able to accomplish this year. And we're really also, even though this is the last for 2020 and 2025, we're still very hopeful for demo days going forward and where we can expand to. I believe that soon, if not now, our demo days presentations are now all on YouTube. They're now publicly accessible. Yeah, like y'all can check out everything that's been on there. And I'm just, really proud of the team and looking forward to this finale in which we will be covering, once again, as we did at the start of Demo Days, PRIMRE and everything the team has been up to. So take it back, John. Thank you so much.
Thank you, Swara. Appreciate it. We'll move on to the agenda. So today we're going to cover a brief overview of PRIMRE and the ME Software Knowledge Hub, as many of you are probably already experts in that, and so we'll keep that fairly brief. We'll also do a recap of the demo days. You'll get to hear some lightning talks from some of our demo presenters. So if you missed a demo day, it's a good opportunity to get a quick recap and a preview of that particular piece of software. And then we're going to ask you to take a survey so that we can build on this series and improve upon it for next year. And we'll end with some Q&A. And so without any further ado, we'll move on and jump right into PRIMRE and the ME Software Knowledge Hub. So the first overview of PRIMRE, the portal and repository of marine energy, provides access to marine energy data, information, and resources. It is an attempt to corral the many different knowledge hubs that existed before PRIMRE came along and to combine some of them into some new knowledge hubs. And so you can sort of see them in that wheel there. We have a whole series of them that I'll get into in a moment. But in addition to our knowledge hubs, PRIMRE also has an events calendar. We have webinars, we have educational resources, data docs, tools, and of course, software. Next slide, please. The 7 main PRIMRE knowledge hubs are the MHKDR, which hosts data from WPTO-funded projects and other marine energy projects around the world, although it's primarily DOE-funded efforts. We have the TETHIS and TETHIS Engineering, both host documents, TETHIS on environmental effects and engineering on technical documents. Of course, Marine Energy Software, the star of this series, hosts codes and software and is what brought everyone together for the demo days this year, and is a great place to find software and tools that you can use to help with marine energy research and analysis. Telesto is our newest portal on PRIMRE. It's where we're hosting testing and measurement guidance. Telesto is organized essentially from the timeline of development from design all the way through production and deployment, with various helpful things along the way that include international standards, guidance, best practices, and lessons learned from the industry. Lots of valuable information in there. We also have the Marine Energy Projects database. This started as a database out of DOE's WPTO office and has been migrated to PRIMRE, where we're keeping it up to date, trying to keep tabs on all the marine energy projects and deployments going on around the world. This has a lot of international data in it as well. And it's a great place to find out who's working on what and playing with what technologies. And so you can search by device, technology type, or company to see who's involved in which projects. Marine Energy Atlas is where we host our GIS-based information. It's our GIS analysis tool. You can visualize the US wave hindcast data set in there. You can do siting and feasibility analysis on specific geographic areas. So it's a great place to do geospatial analysis and play with that type of data that doesn't fit neatly into other categories. Next slide, please. And of course, what we've done as part of the PRIMRE core mission was to make sense of all these different knowledge hubs and make it easier for people to find information in those knowledge hubs. And so one of the main things we did as part of the PRIMRE project a few years back was to develop a standard metadata schema for marine energy metadata. This allows people to search on marine energy related facets, things that are important to those of us in the industry. And we use that metadata schema to get all these knowledge hubs talking the same language so that we can link them all together into a centralized PRIMRE search, which means you can go to PRIMRE and go to search. And if you're not sure which knowledge hub has the things in it that you want, it will search all of them for you at the same time and direct you to results from each of them. This was a really a big advantage. It really made discovering information through PRIMRE a lot easier, but it also had the added advantage of laying the groundwork for PRIMRE's Ask PRIMRE, our new virtual research assistant. Once we had all these knowledge hubs speaking the same language and metadata in place, it was really easy for us to then take that and connect it to OpenAI's ChatGPT. And so you are now able to click the Ask PRIMRE button on the homepage of PRIMRE and open it up, and you can ask our virtual research assistant any number of questions across the marine energy space. And it is filled with the knowledge from all the PRIMRE knowledge hubs, and we've trained it to answer scientifically, always cite its sources, and not go to the internet for answers and not speculate. So we think it's a wonderful tool. We hope you check it out and play with that as well. Next slide. And with that, I'll turn it over to Cesar to talk through marine energy software.
Thank you, John. And just really quickly to talk about the Marine Energy Software Knowledge Hub. I know a lot of the folks in the audience are very familiar with it already, but just so that we're all get an idea of how it's organized. It's largely organized using the study that was conducted a few years ago that kind of cataloged the user needs and input, and that's kind of how it came about. And it has software that is commercial and open source. And over here on the right, you can see the landing page for when you go to the software, and it was recently reorganized in FY24. But that's what you can see here, and there's the URL so you can attend it. And you can go to the next slide, please. Once you dig further into marine energy software, there's a set of on the toolbar of products different features, but the main feature is when you go to, if you click on search software, what you see here on the right shows the database of software, and it is largely a GitHub software collection. And this screenshot here is very outdated, but we currently have 265 software listed in there, and it's all organized, as you see here, by different categories, whether it be technology, a programming language, TRL. So there's a whole suite of that. And then on each of the softwares is on this code card, right? It shows you a link to the software. You can go to the actual repo. It's kind of categorized so you have an idea of what kind of capabilities the software was labeled around. And then specifically for open source software, you can see kind of how well maintained that software is, which can be very useful, especially for open source software. But please, if you get a chance, go check it out and provide feedback as much as you can. And next slide. And I will pass it on to Megan now.
All right. So we just heard about PRIMRE, and we heard a recap of the Demo Day series from Swara, but we're going to dive a little bit deeper into the whole point of this series. So the vision was to increase awareness and use of existing WPTO-funded software and enable cross-collaboration between software with the goal of increasing interoperability because, we have all these different labs and different software developers all working on different projects, and we want to see, how can we make it more efficient for the users? How can we cross collaborate between our software tools? The primary audience was internal only, so the labs and DOE. And we heard from software developers about their software capabilities, and we also had a portion for discussions, again, to increase that interoperability between software. So success for this Demo Day series as we come to a close after this presentation is to complete the FY25 Demo Day series featuring WPTO funded software, which we're doing. So I would consider this a success. So this was the schedule. We started off with a primer kickoff. So we've kind of come full circle here with the primer finale. Then we heard from the Wexim team, OpenFast, Moredyne, MHKit, Embari WEC, and then WEC Tool. The software outlined in green used a online collaborative software hosting platform called CoCalc. So if you attended those sessions, you should be familiar with that tool. And then the ones in black didn't have those capabilities, so we weren't able to use the software. All right, so each of these presentations was recorded and posted publicly, as well as, this presentation will also be recorded and posted publicly. The QR code at the top of each of the next few slides will take you to the OpenEI YouTube channel and directly to the video of, whatever slide I'm presenting. So this QR code will take you to the primer kickoff video. So like I said, the first demo day presentation was from the primer team. We heard from Cesar, John, and also Jonathan Whiting, who are the primer PIs, about primer. And now that you're familiar with it, based on what John and Cesar said, I'm not going to bore you with the details, but essentially they gave a similar presentation, shared our screen, kind of talk through the different knowledge hubs a bit more in depth during that. But you can find that recording using that QR code on the top right. Next, we heard from Kelly and Mohammed from the Wexim team. Wexim is an open source software for simulating wave energy converters. First, they gave a presentation about Wexim in general, the general workflow of the software, so going from BEM, building your Simulink model, building your Wexim model, and then getting an output. And they also talked about, they shared their screen and talked about how you could use Wexim kind of in real time, and they shared a demonstration of the RM3 model, which you can see in the top right. There's like a little mechanics explorer view from MATLAB. This is built in MATLAB, so we were unable to use CoCalc, but I think the demonstration went really well. And again, you can see the recording in the top right there. Next, we heard from Hannah Ross about OpenFast, which is a multi-physics, multi-fidelity tool for simulating the coupled dynamic response of wind and marine turbines. This demonstration did use CoCalc. Hannah started as well with overview presentation of OpenFast, the theory behind it, the workflow, what it's used for, and then pivoted to using the CoCalc platform where students and attendees of the demonstration were able to log onto their own CoCalc account and kind of, run code in real time alongside Hannah. I think she ran a few kind of like Linux terminal style examples and visualized the outputs in py.view, which is a Python visualization package, and ParaView as well. Next, we heard from Ryan Davies about Moredyne. It's very coupled with OpenFast and other software like Wexim, so the workflow made a lot of sense having this, where it was in the series. Moredyne is a versatile and efficient lumped mass mooring line model intended for coupling with floating structure codes. Ryan also gave a theory presentation, capabilities of Moredyne, and also used CoCalc, very similar to the way Hannah did. Walked us through a Linux terminal, some commands, and how you can modify your input files to get the exact kind of outputs regarding whatever needs you have for whatever project you're working on. Next, we heard from the MHKit team. So we heard from Adam, Andrew Sims and James McVeigh, and they presented on the Marine Hydrokinetic Toolkit, which is a free open source software for processing, analyzing, and visualizing marine data written in Python and MATLAB. So by the nature of this software being, having a Python and a MATLAB version, they gave their overview presentation of MHKit kind of as a whole, and then Adam gave the Python version demonstration in CoCalc, where users were able to go in and run a PackWave resource assessment example using MHKit in a Jupyter notebook. And then I believe it was Andrew who took over and kind of ran the MHKit MATLAB portion of things. Next, we had Andy Hamilton and Michael Anderson from Embari WEC. It is a simulation software that provides the same interface as the real hardware on Embari WEC, on the actual Embari WEC device, which is deployed roughly 6 months at a time out near the Embari WEC lab. It allows projects the ability to develop and test their work independently before deployment on the actual system. So again, they gave a presentation, they gave us a walkthrough of their simulator. I was really interesting. Honestly, I didn't really know a lot about the Embari WEC device, and this, the capabilities that you have with the simulator, being able to kind of practice everything before actually running tests on the Embari WEC device itself, I thought was extremely interesting. So definitely check out this recording. Again, QR codes are recordings for these presentations on YouTube. And lastly, well, I guess not lastly, this is the last one, but the one before this, WEC Tool, we heard from Carlos Michelin and Daniel Gabele about the Wave Energy Converter Optimization Toolbox, and it's an open source software for conducting optimization studies of wave energy converters and their control strategies. So this demonstration also used CoCalc. It is a Python-based software tool. So we ran through an example on there. There was also an example using the WaveBot tutorial that the group had developed, and we heard about the different, kind of problem setups for the optimization problem that WEC Tool uses, how BEM is used, kind of the whole workflow of, starting and getting your optimized control strategy and results. Okay, and with that, we're going to pivot a little bit. We just talked about everything that we were able to include in the Software Demo Day series. These aren't the only marine energy relevant software that, we use on the day-to-day basis in the industry. So we kind of wanted to have a little spotlight on the software that we weren't able to include this time around, but, maybe next year we can have a full demonstration of these tools. But for now, we're going to get a quick 3-minute overview from these different software point of contact. And Mohammed, are we ready? Because the timer's going to start.
Yeah, I'm ready.
Okay.
So we start with the Capitaine. It's a linear floating multi-body dynamics solver in Python. It started in 2018 by a company. It's called Muse Lab in France. It was based on Nemo. They were just trying to enhance Nemo and make it more accessible by having a Python API for it. And then NRELS and Sandia started funding the project in 2022. And the main goal was to try to make Nemo more accessible, because first of all, Nemo was written in Fortran, and it wasn't really like, when you read the variables there, it's very abstract. You can't really make sense of what's happening, and all the documentation was in French. So you can't really work with Nemo without having a Google Translate with you. So the goal was to rewrite some of the functions, or many of the functions, in Python, and also change the variable names to make them more readable, and also write documentation that's in English that everyone can understand easily without the need for a translate. So Nemo we are currently at version 2.2.1. It was released a few months ago. It solves first order potential flow, gets the added mass, radiation damping, the excitation forces, and this is like ground zero for many of the other softwares we have here, like WECSIM, CStack, WakeUpTool, and many other projects that rely heavily on these BM solvers. There are some enhancements that were done recently in the finite depth and deep water. It's some enhancements that were done with the modeling flexible bodies and multiple bodies, the interaction between them. And also the implementation of the forward speed was added last year. Also, another feature that was added recently is the irregular frequencies removal, which is a key feature, especially when you have multiple bodies standing close to each other. And also parallelization was added. And tests were done on normal HPCs, and also we will start testing on GPUs in the next months. There's an upcoming release, it's 2.3. It includes more robust finite depth resolution and optional HAMS backend, and also it can export WAMIT outputs. So you can just have the conventional .out file that you get from WAMIT. So it is accessible and transparent. You can get the documentation easily, and we also have some examples on the Wexim repository on how to set up a model. Pretty straightforward. The license is currently GPL, and we are trying to go to a more permissible Apache 2 license. It is modular, and it can be coupled with many other softwares. And also, we are doing some experiments with these high-performance computers that makes it much faster than any other alternative we have out there. Yep, and that's it for everything. Hopefully on time.
Great, thanks. All right, I'm gonna go to the next one now.
All right, so my marinehydro.jl, it's a differentiable BM code. So just like Capitaine, it's a BM code. It'll get you your added mass, radiation damping, excitation coefficients that you can then use to calculate the linear hydrodynamic forces. And it's done in Julia. We wrote it in Julia in order to be differentiable. Capitaine is written, the front end is written in Python, but a lot of the calculations are in Fortran, and it would have been very tricky to make that differentiable to begin with. The reason we were looking for differentiable BM is because in many of our work flows, like Wake-up tool, in order to optimize a variable, we need all the calculations involving that variable to be differentiable, so we can get the gradients to do gradient-based optimization. So in Wake-up tool, we were limited to not being able to really optimize, say, geometries because the BM, the hydrodynamics was not differentiable. Similarly, our partners, we partner with Dr. Maha Haji at Cornell. They do multidisciplinary optimization where they optimize, let's say, a offshore autonomous vehicle platform that has a hydrodynamic model, a telecommunications model, a propulsion module, and everything was differentiable except for the hydrodynamics. So they were also limited to not being able to optimize the geometry of the platform. So we decided this was important enough to write our own BM code from scratch. We did this through two seedlings. It was a partnership between Cornell, Sandia, and then the developers of Capitaine. So they were very involved in this project. As the output of a seedling project is not very feature robust or user friendly yet, we were hoping for a sapling, but there was no call this year. But we have some plans to move it forward with other funding. But we've verified it for single bodies. So for example, here for a sphere, you can see the results of our BM compared to the theoretical coefficients for a sphere, as well as the results of the gradient with respect to the radius compared to finite difference. And it matches pretty well. And we just made it open source, and we'll be presenting a workshop at UMERC on August 12th if you're there. Yeah.
Thanks, Carlos. All right, next.
Hi, everybody. My name is Elise Bayat, and I'm here today to talk a bit about some work that was done with my two colleagues, Jessica Nguyen and Chris Chartrand at Sandia. And that work is on the development of a graphical user interface for the computational fluid dynamics library OpenFOAM. So OpenFOAM is open source and freely available, but it can often be difficult to use with steep learning curves because of its text-based interface and just kind of like complex configuration files to set up simulations. So to kind of alleviate that and make OpenFOAM more accessible to a broader user base, we've gone ahead and developed a graphical interface in collaboration with the company Kitware, who are known for being developers of ParaView, the pretty popular visualization software. And so what that does is just provides a centralized graphical location to do all the simulation design, setup, and running the simulations that you would typically do in OpenFOAM in a software that's familiar to many because it's so similar to ParaView and it has a very similar look and features as ParaView. And so we can do a lot of things in here like importing and transforming device geometries, all of the mesh construction and management for both the simulation domain and devices. So it is done in the software in a kind of point and click format. So we can do things like set up refinement zones, develop the overset mesh, etc. All in the GUI. We can also do things like set the boundary conditions and wave conditions. So the simulation setup for the physics and even add simple restraints like simplified tethers in a point and click format. And all within the GUI. And the other thing that's really nice about it is that it's been designed in kind of like a component-wise plug and play way. So we can, for example, like design just a wave tank study, and then you can, in the same project, copy it and add a device, copy that and add more and more complexity. So you can do all the steps that you might do for a full like WEC analysis pipeline in the GUI in one project. And within the GUI, like all the OpenFOAM dictionary files that you need are auto-generated and managed by the GUI. And at the current stage, this is specific to WEC simulation, but we're currently working on expanding and adapting the software to be more generalizable with broader customer bases. So if there's any cases or features that people are interested in seeing like put into this, please let us know, or also if you're just interested in testing out the software. And then Jessica and I will be presenting a poster at UMERT, and we're going to be doing software demos there. So please come by our poster to chat and check out the software. Thank you.
Perfect timing, Elise. All right, I think Owens is next.
Yeah, thank you. So Kevin Moore from Sandy National Labs here. So Owens was originally the offshore wind energy simulator coming out of the Wind Energy Technology Office for floating offshore VOTs back in the 2010, 2013 time frame. And it's also been used for numerous other applications, from distributed wind to some advanced concepts with ARPA-E, and most recently for marine and hydropower. And so we've added on some things onto the name there in the acronym, but specifically, so Owens is it's an aero hydro servoelastic solver, and it's been designed tailored for advanced concepts. Typically, we've worked with cross flow turbines, but that's not necessarily what it's limited to. And what's really unique about it is that, like the code that Carlos had presented on, is that we've targeted the automatic differentiation, and that enables the AI-driven autonomous design optimization. And so it's written in Julia. All of the .jl packages are written in Julia, and it pulls in. Owens itself is an ontology, and it pulls in the different aspects from the pre-processing coming from pre-comp, so that we get the detailed composite layups for the blades, the towers, struts, different components that we might have. And then that goes into the 6x6 beam finite element analysis. And then we get forces from the aerodynamics, either from the built-in Julia aerodynamics or from a coupling from OpenFast to the Aerodyne, and we also have coupling to OpenFast for Hydrodyne, Mordyne, and also TurbSim. and inflow wind, which enables us to do the wave and inflow superposition. And with all of that, we can do our steady and unsteady and modal analysis, and we can do things, fully coupled fluid structure interaction. And so, and then we output all of that with PRIMRE. It's designed to work well with PRIMRE, and that's where all of the images on the right come from. And remembering that we started with pre-comp and the detailed composite inputs. Because we did that, we're also able to do the detailed stress and strain analysis on the outputs. And so in the upper right-hand image, you see there's sort of a surface profile, and that's the stress of the blade under those conditions. And so we can get those detailed, even within the intra-laminate stresses. And so we can do highly detailed design. So please feel free to reach out if you're interested. Thank you.
Great. Thank you, Kevin. All right, I think next is Sam.
Hi, my name is Elena Baca, and I'm from the National Renewable Energy Laboratory. And today I'll be talking to you quickly about the System Advisor Model, otherwise known as SAM. So SAM is a free and open source techno-economic software developed by NREL with funds from the U.S. Department of Energy. The tool is used to evaluate the power performance and economics of many different types of renewable energy systems, hybrid systems, and battery energy storage systems. The marine energy module was added in 2019. Which models wave energy converters, tidal energy converters, and wave and battery hybrid energy systems. So at its core, SAM uses a standardized analysis framework and also follows analysis recommendations provided by the Department of Energy's Water Power Technology Office. SAM models the power performance of marine energy technologies using limited data from the limited power data of the technology in question, but also if users want to just explore other technologies, we have a full technology library with power matrices for many different types of wave energy converters, as well as power curves available for different tidal energy converters. Additionally, we have a library of both wave and tidal resource data that's available for use within the tool, as well as available for download for external use. And lastly, for our power performance modeling, we do have a tidal rotor design tool, so people can do kind of quick power performance what-if estimates, just evaluating tidal systems of different rotor diameters. SAM models the economics and cost of marine energy systems using the marine energy cost breakdown structure, and uses standardized financial assumptions and the recommendations provided by the Department of Energy. We also have built-in cost modeling cost equations, which people can use to estimate any unknown costs for their systems. And of course, users can input their own custom costs for their marine energy systems. Lastly, the tool puts this all together to output usually the levelized cost of energy, although users can opt to only simulate the power performance of their technology or system. And SAM estimates many other metrics such as CapEx, OpEx, capacity factor, average power, and many other cost and performance metrics, while also offering standardized reporting, visualizations, and many built-in comparative analysis tools just within the model itself. And lastly, to learn more about SAM or download the tool yourself, please visit sam.nrel.gov. Thanks.
Awesome. Thank you, Elena. All right, I think C-Stack is next. There's David. Sweet.
Hey, so this is the last lightning talk, so bear with me, everybody. Yeah, this is a new project that's just started a few months ago, Project C-Stack, and this is a very brief overview of what this project's about. And in a nutshell, I suppose it's about increasing confidence in marine energy systems through next generation simulation tools. And as the name suggests, this is a stack of codes. Within CStack, there's multiple different components. And under the project, we'll be developing new codes and also using existing codes like Capitan, like OpenFOAM. And I suppose the key words to take away are interoperability and developing a framework where these codes are working well together and we can easily transition between different codes. And capabilities, we want to introduce new simulation capabilities that we really hope can lead to some breakthroughs in the marine energy technology that we really need. So why it matters. So before deploying anything at sea, developers and investors need to have confidence in what they're deploying, particularly that it's going to perform well and that it's going to survive. So we use numerical models to build that confidence by exploring different design options and by simulating extreme conditions and making sure that things are going to go well before we commit to those expensive high-risk ocean trials. And the current challenges that we face with existing codes and some of the things that we've tried to learn from existing codes and take forward into this project, that a lot of the time they're fragmented. It's kind of been alluded to today. They kind of sit in their own silos, they do their own job, but really, to get to the ocean, you need to be using lots of different tools. So in this project, we want to reduce or eliminate some of those hurdles between bringing these tools together. I'd say a lack of interoperability between tools is really limiting innovation in the space, and it's really limiting system level design optimization as well. The other thing is that anything that we do at a low fidelity for design optimization, we want to easily be able to validate with a high fidelity simulation. And that's probably the biggest gap in the space at the moment, the gap between low fidelity simulations and high fidelity. So building that bridge is a key goal of this project. And I've tried to illustrate that in the diagram, that we've got this optimization loop where we're coming up with an optimized version of this centipede WEC. And then we drop that into a high fidelity simulation and we're investigating drag and extreme loads and everything else. So, the vision is this is going to be the next generation 100% free and open source simulation framework. We're prioritizing speed, modularity, interoperability, extensibility, new capabilities for flexible bodies, for collisions, for novel PTO types like TENGs, for novel control systems. We want to be able to simulate interactions between devices and vessels, more accurate soil models. Very ambitious project with a lot of new capabilities coming into it. I suppose I'm over time, so I better wrap up there. But we're very early in this project, but watch this space, I suppose. Thank you.
Awesome. Thanks, David. All right, and I think we're going to hand it back to Cesar to close us out.
Thank you, everyone. Really great list of software there to talk about. But next slide, please. So first thing is, I really want to thank Kelly Rule, Megan Anderson, and Dominic for putting together software demo days. It went together really well. But of course, there's some ways that it can be improved upon, and that's what we have here. The QR code that you see on the upper right will take you to a SurveyMonkey survey that takes about 3 minutes to complete. If you can, please complete it. You can use your phone and access it on your phone. We will also post a link to it in the chat so people can access it if they'd like. But we were also, it was included in the email that Megan sent out as a reminder for this one, and we might send another reminder out in a few days or so, maybe next week. But it will be open for about a week or so, maybe a little bit longer if we were looking for a larger response. But again, as Suara alluded to at the beginning, we think that this event, this demo day series has been very successful. There's a lot of interest from WPTO and from the PRIMRE team to keep this up, to feature some of the software that you just heard about, but there's plenty of others that are out there. And so anything that would improve upon this event, please look forward. And it'll be not only talking about how it can be organized better, but also what you thought about CodeCalc. We're very interested about how that worked out. But next slide, please. Second, as we said, is the marine energy software. We want people to start contributing their software that we don't know about. And what we have here is kind of like this quick animation of how you would go about contributing to MA software. So what you see just kind of looping there is if you go to the Marine Energy Software Knowledge Hub, you go up to the toolbar where it says register software, and it'll direct you to the GitHub page for this that has the hosted database, and it'll list there just the set of steps that you need to do to create a pull request that will initiate so that we can, once you format your contribution in the correct way, then it will be reviewed by the ME software team, and they will let you know if anything needs to be changed or if it's just accepted, and you will be listed on the actual database. But please, if you have anything that you want to contribute to it, there is the steps that you can follow. But also, if there's any confusion, just please reach out to the PRIMRE help, and we'll be more than willing to help you do this. Next slide, please. PRIMRE doesn't just host software. We also host, as John said, we data documents. So we also have a set of like what we call disambiguators for that kind of walk you through if you have something that you want to submit to PRIMRE, but you're not exactly sure where it should go. So if you click on the contribute to PRIMRE, there's a page there, and there's actually like a form that you kind of walks you through what you want to submit. There's also a different form for contributing to MHKDR, and there's even a recording there that was done a few years ago as to kind of walk you through how you would submit your data to MHKDR so that it's not only logged for, to be used well, but so that it's also logged in case this is from a WPTO funded project, so that it's done appropriately, barring the way that funding mechanism works. But please, and as always, if you need any help, please email us and we'll walk you through the whole process. Next slide, please. PRIMRE is very active on social media, so please follow us. But we also have these two sets of newsletters that go out. Each one goes out bi-weekly, and there's the Tethys Blast and there's the PRIMRE Blast. And here we have just announcements for funding opportunities, job announcements, new papers that came out, new content on PRIMRE. So that QR code that you see there is so that you can subscribe to the blast, and they go out every Friday morning is when I get them in on my inbox. So please follow us as much as you can. Next slide, please. And we are at the end here. I want to thank everybody here for participating. Again, thanks to Kelly, Megan, and Dominic for helping run this. Up here you see is the QR codes again for software demo days and for the Tethys Blast. So please provide, follow us and provide feedback as much as you can. What we want to do now is open the floor for Q&A. You can ask questions about demo days. You can ask questions about PRIMRE or any of the software that was just featured here. But I'll go ahead and open the floor to that. Thank you.
Thanks, Cesar. Any questions? It can be about demo days, any of the lightning talks we heard from. Did you like demo days? Did you hate it? Anything.
Yeah, if anybody here just even just unmute, like we had previously talked about having a more like in-person thing, which we couldn't end up doing, but would it have benefited from a more interactive, like in-person kind of event, or does this kind of web-based function work for people? And please let us know. You can do it here or in the survey if you get a chance.
All right, thanks everyone so much for attending.
Yep, thanks for your time. Hope you all have a great holiday weekend, and we'll see you at the next demo days. Hopefully next fiscal year sometime. Thanks.
Yeah.